Suitable. Great. Hello everybody. My name is Silén. I'm happy to be here in Göteborg for foss-north. I'll be talking today about about using AI responsibly with transparency on your own data. And that was mentioned by the previous speaker. That will be RAG, which is a technique we'll be talking about. But I'm representing here today MariaDB Foundation from the MariaDB database. I'm based in Finland, Helsinki, and happy to be talking here today. So I'll be using as a use case something we've been. Oh, sorry, I'll jump forward. Great. So to get straight to the point, why transparency on your own data? So what we were just looking at in the previous one was where you prompt an LLM and you get an answer. And I'm sure many of you have tried ChatGPT and others and you simply get answers. And you don't know what exactly it's based on. And that's probably great in situations where you're asking for a funny joke or a creative response to something, draft something. But in some cases it matters a lot that what you're working with, that you get sources, you get accountability for what you're using, and you get exact pinpoints of what is being used to give you that answer. And for that, RAG is a great solution. Sorry, I'm not seeing the slides here. So to use an open source database for a RAG solution, you have all your data in your database that you want to use to produce answers. And in addition to that, we want to vectorize them, store them as vectors, so that you can easily get related context. And then with single queries, we can combine those vectors with standards data. And these are all great reasons why you want to put your data and vectors in the same place. But now I'm getting ahead of myself because you need to understand why vectors are needed when doing RAG. And these are some of the reasons why you want to have them in an open source database. But let's back up a little bit and get to the use case that I want to present with you, so that we'll take it really from the basics why we're doing it in this way. So the agenda for today is I'll explain the RAG use case on using Wikipedia, and then we'll go in on what is MariaDB server and why you want to use an open source database for RAG. So, switching context to Wikipedia. How many here have edited Wikipedia? About half, maybe. How many of you know about what Swedish Finland is? Some of you have heard about it. So, the group Kai that recently won Melody Festival and will be representing Finland in Eurovision are a representative of our small minority. So it's becoming many more people know about it. But some of you know, based on the laughter, I see that many of you maybe know Kai, but how many of you know what Österbotten is? Wow, even more. Okay, well, great. Well, that's sort of what Project Fredrika has been working on, to improve the representation of Swedish Finland on Wikipedia. So Project Fredrika is a non-profit founded in 2019 by Guy Arne, who also works for MariaDB Foundation, and I've been involved in that since the beginning. So you could call me a co-founder, employee, Wikipedian in residence. And the name Project Fredrika comes from Fredrika Runeberg, who was the wife of the national poet of Finland, so he wrote the words to our national anthem in Finland. And Fredrika was a novelist and one of the first authors in Finland. Now, back to Kai, since that brought out a lot of laughs here. So, the Wikipedia article for Kai, and related articles like it, like Österbotten and Böro, where they come from, they got a lot of hits around and after Melodifestivalen, nearly 100 times more than the previous 12 months. For the month of March, you got over nearly 100 times more than the previous year. So it's definitely not trivial what it says on Wikipedia about Kai or any articles that people are interested in. These are statistics that we brought out on several different languages for the past month and the past year for some related articles to Kai. But what makes Wikipedia reliable are its sources. And it wasn't always like that. So in the beginning, you could write pretty much anything on Wikipedia. It was maybe quite a Wild West. Anything went, and nobody really knew perhaps where it was going. And that's maybe partly where we are with AI today. The processes and guidelines and fair moderation is only starting to appear now. And Wikipedia has a lot of that. There is a community and there's a lot of policies behind it. So any addition to Wikipedia needs to be based on external sources, and that kind of reliability, trust, openness, and possibility to edit and influence is what makes Wikipedia so central to the internet and to anything digital, really. So with Project Fredrika, our first concept project was to improve content about a small place called Nagu, south of Åbo in Finland. It's a former municipality with thousands of islands. So we improved hundreds of articles on Wikipedia and also about the over 1,000 islands. Wikipedia is a community effort, but with our encyclopedia of Nagu, we learned that even though Kai and I were really excited about editing Wikipedia, it was a struggle to get local experts in Nagu to give feedback or to prepare. Well, they could give feedback on prepared material, but to actually get them editing was a lot more difficult. To actually get them to become Wikipedians, that was a step too much. So what we learned from that experience was that sources are really important, not just experts, but sources. So since then, our projects have moved on from themes like Nagu to sources around Swedish Finland. And that's where we can be experts both in Wikipedia and editing content and put it in sources. So we've been doing projects around bibliographies or book series. And that's perhaps where the challenge has appeared for us. How to find the right piece of information in these vast sources and find the right Wikipedia article that we could use to improve with that source. And how to do all that at scale. So these are some numbers of what I've done as a Wikipedian in residence over several years. And a lot of those edits are quite small additions, small bits and pieces that we have added. And I'm sure that could be better if you had a little bit of help, maybe AI help. So from there, now that I've given you some context, let me jump to the more visionary slide. So the idea for RAG, for Wikipedia editing, would be to have a human AI co-editing system where AI identifies where there's gaps or things you can improve in a Wikipedia article and then suggests what could be improved in that article, but based on sources. So it has to be an external source to improve it. And we don't want to give AI the right to just edit anything. We want human editors to then verify those suggestions that AI gives, so that we know that that what it's suggesting is really true, and the reins stay in human hands. And Wikipedia has those policies already from before on how to respect NPOV, which is neutral point of perspective. They have an encyclopedic language, we want to respect that. And as I mentioned, these sources, high quality sources, are necessary to keep a good quality in Wikipedia. So how do you do this with RAG, which I'm mentioning? So we did a pilot project for this, and these are our basic steps for how to improve Wikipedia. So start by identifying a great source. We used for this project a book called Et gott parti, which is about Albert Edelfelt and his wife Ellen de Chapelle. Albert Edelfelt was a very important painter in Finland in the 19th century. He painted a lot of important paintings for Finnish nationalism, but he also traveled around Europe, a lot to Paris, to France, and he painted the elites of the time. And one famous painting, for example, is a painting of Louis Pasteur, so a very renowned scientist at the time. So the Wikipedia article about Louis Pasteur has Albert Edelfelt's painting in it. So he was traveling around a lot to do his painting gigs, if you may. So he met a lot of important people, visited a lot of important places. So there's a lot of things that could be improved in Wikipedia, but from here and there in that book, it's all spread out there. There's no real index. There's no, here are all the pages where Louis Pasteur is mentioned. And I have to give credit to his wife also. Ellen de Chapelle was very good at mingling and getting these gigs for his husband, Albert. Okay, so the step 2 is how do you find all these people and places that could be improved from this source? And for that we used NER, Named Entity Recognition and Vectorization. So we were looking for specific places and names that we could tag with a Q code, a Wikidata Q code, which is then connected to all the Wikipedia articles for that thing. Although Louis Pasteur has one Q code and it's connected to a lot of Wikipedia articles, so you know which languages you could improve with that. And also by vectorizing, you vectorize the content of a book and you can compare that small piece in a vector format with Wikipedia articles vectorized, and then the ones that have a closest vector, you realize, okay, this can help in improving this, so you get matches by vectorizing. I'll go into this a little bit more in a moment. And then the step 3 is to give that result to an LLM, to ChatGPT, Claude, any of these, with a clear instruction. So use this source, it's in plain text. This is the bit about Louis Pasteur, how Albert was painting him. This is the Wikipedia article. The article about Louis Pasteur is very long. You might have to break it down for it to fit the context window in some smart way. And then you give a task. So improve this using this, and the output should be in a certain form. And then you get these suggestions, and as a human you review these suggestions and then you put them into Wikipedia, and you have a clear source from the book. So this was how Albert painted Louis Pasteur was mentioned on page 46 in this book. It's clear source. So what was the result of this? We found 278 unique people and 265 places in the book. And then with the method I just explained, we generated Wikipedia improvements, Wikipedia article improvements on that. We actually had the privilege of having Maria Vainakurtakka, the author of the book, was involved, so she could actually evaluate if these suggestions made sense. And 1/3, she thought, yes, absolutely, put it in. 1/3, she said, that's not quite right, it doesn't quite fit into the flow of the Wikipedia article, or that's actually not true. And then 1/3 she dismissed, like, no, this is BS, this is not correct. And there were like 2 main challenges. So the first was matching content. So Erik was mentioned a lot in the book, and AI thought that was Eric the 14th. But that was actually Albert's son. And then Alexandra was also mentioned a lot, and that was Albert's mother, but that jumped to Alexandra of Denmark, and he did not paint her. You learn a lot when you do these things. So getting that correct match, that's a challenge. Maybe if you give more context to it, AI will realize, well, in this context, it's probably not Eric the 14th, but something else, but then he might suggest Eric, some ice hockey player, I don't know. Well, maybe not 19th century, but still some other Eric from 19th century. And the second category of challenges is that AI would be able to assess that, no, I don't have enough good sources to actually produce a suggestion. Simply say, no, the sources aren't good enough for this. And we were pushing it. This third that was dismissed, like when I actually looked at this is the bits we gave it to it, I was like, no, this wasn't supposed to make sense. AI should have itself dismissed that third. It's not like we were giving it anything reasonable to use. And if this was to be a real process, we would want AI to drop out bad input, bad suggestions, and not try to please us by generating something. So how did I do this? I have a slight coding background, but I'm not a super coder. So I love coding with AI because I don't get stuck on the details. I quickly get stuff done. So I'm using Cursor, which has Claude, and that you can get into a nice flow with that. Maybe some of you have heard about vibe coding. I definitely feel that type of flow when I'm doing stuff. The second point about how this was done, chunkification. So when you're splitting the original source into smaller parts to analyze it, to vectorize it, or to otherwise, you want to make smaller pieces so you can feed it into, hey, use this to generate a suggestion. So that chunkification is surprisingly important. You have to, context windows were mentioned in the previous talk, and even you have Gemini with 1 million token context window, but still you need to focus the AI, like use exactly this. This is what we're after now. And so you have to figure out, are you doing chapters or pages or paragraphs or even sentences? On what level are you, would make sense to do this? And I mentioned this NER, so yes, you can use AI to sort of link together, but in some cases, link together, so okay, so we have, well, if it was Alexandra of Denmark, this is her Wikipedia article, but there's also a more simpler tool called, from the Spacey large model, which also has a plugin, so you get the Wikidata Q code immediately. So that's pretty cool when you find these sort of small open source tools that help you along the way. And then a quick comment about the language models used. So I tried them all, and this was a few months ago already, but at that point Claude was giving the nicest output to use on Wikipedia, so it was very it has a much more objective output, whereas OpenAI's ChatGPT has this tone of being an over-enthusiastic job applier with a lot of adjectives, and that doesn't really fit into Wikipedia. And I also tried Mistral and Google Gemini, and unfortunately, I'd love to root for the European Mistral, but that was a bit weak maybe, and Google Gemini was at that point going off on tangents. Yes, so I mentioned the chunkification, that matters, and perhaps one more comment on that when you identify, oh, this piece of information from the book could be of use in the Wikipedia article, you maybe identify that certain paragraph to be important, but then for the LLM to get it, you should maybe actually also feed it the previous and following paragraphs, or maybe even the whole page, so that it gets the whole situation for that one thing. And then another point is if you really want to do vectorize, do this vector comparison between a book and Wikipedia, a dump of Wikipedia in all languages is 76 gigabytes at the moment as a zip file. So putting that into a database just to find certain articles is maybe overkill, so do a subset. And I mean, it's not a problem for MariaDB, the database. It has been tested on very large vector amounts, but for your own time and money to generate those vectors could be it's good, a subset. And I've also found some pre-vectorized datasets in case that's interesting for you. Do have a look for that. If you're more interested in the results of this particular use case and project, there's a Wikipedia project page about this where I've shared more details about how this was done. So for future, sort of using this for future RAG solutions for this particular use case, yes, the LLMs are improving. They can focus better, less hallucinations. There's a lot of RAG frameworks coming out. Has anybody tried here RAG or any of the frameworks for it? Sorry, RAG? Frameworks for it. Okay, both, okay. So LangChain and Llama Index and these types. So I tried them also, but after you sort of get going with these frameworks, but then when you actually when you want to tinker, you realize it's just getting in the way, and I ended up writing raw Python to just get at it and do this RAG process myself. But the RAG frameworks do give you an idea of what would be good prompts or what's a good trunkification strategy, and also how to utilize AI, like AI agent workflows, is that it's doing several steps by itself, the AI, before it gives you a response. Graph database approach would be that it's actually creating claims from the article, figuring out facts from the text, and then you use that in your work. And multi-hop looping, this will that one will make more sense maybe when we go into the vector search, but so actually the process is refining the user query. You type in something, but that question as such is a bad output to get the answer. So you actually ask the LLM first to refine what should I be looking for, and then you search for the right context to be able to answer that question. But as I put here, every use case is unique, so you need to figure out how to do RAG on your own data or your own book or source or whatever you're wanting to use. And now I'll jump to, where did my browser go? I'll open my. That would be a good idea. Okay, let's.
Oh, you broke it.
Okay. Okay, so let's go a little bit deeper now in the technical process of what's happening in a RAG. Are there any questions so far about this use case? Otherwise, I'll proceed to. So how many here have used an open source database? Wow, most of you, great. MySQL, Postgres. Has anybody tried vector databases, vector storage databases, Quadrant or, no, not that, no? Oracle? No, okay. All right. So MariaDB, have people been using MariaDB? Yes, we see some hands, great. So it's a mature extended fork for MySQL since 2009, so it's already been around for a good while. You can just switch MySQL to MariaDB. It's fully open source. We claim it's more performant, and it is according to several tests. and it adds a lot of functionality on top of MySQL. So if you want to switch your Oracle database, you just add SQL mode Oracle, and you can actually switch your application to be using MariaDB instead of Oracle, which is something maybe that would not have been implemented in MySQL if you know who owns MySQL today. So, what AI functionality does MariaDB have? So I've been mentioning MariaDB Vector. So that's a newest feature of MariaDB. It was co-developed with Amazon and MariaDB Corporation's Sergey Golubchik and Vicencio Ciobaro at MariaDB Foundation. So we're a database, so we store and search vectors. You decide how you create those vectors using embedding models at OpenAI and other embedding models. And MariaDB then stores and indexes them. So those vectors can be from text or images, videos, sound. MariaDB can then search those vectors, so you find the closest, the nearest neighbor to the vector you're searching for. So you know what's the closest relevant content for, closest vector to what you're searching for. And you can combine this with other criteria. So if you have you can do a where condition where you're saying you only want European books or American books or whatever when you're searching for nearest vectors. And that's exactly what a standard open source database is supposed to do, to store and search. So what can you do with vector storage and search? Well, I've been mentioning RAG. So classic RAG is that you build your own sort of specialized generative AI, and then another use case is, for example, smarter generic search. So in online stores, when you have, we also recommend this and that, it can often be implemented thanks to vectorizing products or user profiles and so on, and then you do a vector search for what matches, what is closest to this, what this user might be looking for, and gives a best guess response to that. Okay, so let's go in on how RAG happens from a more technical point of view. So I'll show this image first, and then I'll take it step by step. But there's two phases. So the first phase is when you're preparing. I was mentioning in the use case vectorizing the book. So you have your reference documents, you chunkify them, you make smaller parts of them, so that when you vectorize them, one paragraph, for example, is represented by one vector. So that vector gives, or embedding, you call it, that embedding represents in a mathematical way that piece of text. And then you store those vectors in a database. But you also store the raw text, so it's not just vectors, you also have the text there. And that's your preparation. And then at query time, when you actually use your RAG chat interface, the user writes in a question, and that question will be vectorized with the same model, the same embedding model that we used to embed the actual document. And then we do a vector search using that user query. And we find the pieces of text that are closest matching to the user query. So up until now, we've just been doing using vectors. No LLMs yet in play, just embedding models, vectorizing, and searching for closest vectors. Then when we found the closest content to the question, then we feed that to the large language model in the same way as I was presenting earlier. Using this context, answer this question. And then the actual answer is generated. So to take that one more time, you're creating your specialized chat GPT, and that means you want to yeah, you have some sources that you want to be able to answer it. I mean, this is useless if you have 1 page of text. You don't need RAG for that. But let's say you have 1,000 pages of text, and you want to have a chatbot that uses that documentation to answer a question. And you want the user to input a free-form question. And then this makes sense. And as I mentioned, you first embed the text mass. Well, first you make smaller chunks of it, then you embed those chunks and put it into, for example, MariaDB. And then you have it stored and indexed in the database. And then in the second phase, when you're actually retrieving it, when you're answering questions at runtime, that question is transformed into a vector. You compare it to the vectors you already have in your database, and you know what pieces of content are relevant to answer the user, and you will give that to the LLM together with the question to produce the content. I really like practical examples, so that's the prompt that you'll be giving the LLM. You are tasked to answer a question using only the following information. It doesn't have to be 1 chunk, it can be perhaps the 5 most relevant pieces of text from your documents. This is a question for you to answer. And then you also ask it to give you that source, so you know where it's from. And that's, I guess, the key difference to just using an LLM, because it's anonymous. But in this case, we actually want to know the metadata. We want to know what it's using, or what has been used to be able to answer your question. So for the use case that I was explaining earlier about l'autre partie, so this is what a prompt there may have looked like. So first you're giving it a task, and you're not even giving the actual question there yet. You're just saying you're a Wikipedia bot that uses only given sources to improve Wikipedia articles. You follow general principles of Wikipedia. You will need the following material to complete the task below. Then we get metadata of the source, then the chunks that we've identified with vector searches that are relevant for the question. And then we actually give the Wikipedia article that we want to improve. And then we give the actual task instructions, what we want to do with that. But of course, in the case where you're asking questions based on your 1,000 documents, then you wouldn't have the Wikipedia article, and your task would be the actual question that the user is asking from RAG. Has anybody been doing prompts to this extent where you're... No hands? A few hands? So I've done this prompt with XML. I mean, you can also feed it in JSON format or something like that. But if you give some XML to the large language model when you're feeding it with this much context, it makes it very clear for it what's what. I mean, in the use case, I was even noticing it that if the source didn't have enough information, it was actually taking content from the Wikipedia article and like re-suggesting it to me. So it was a bit not quite staying in the right perimeter. But yeah, if you Google OpenAI prompt engineering, you'll get examples like this, how to optimize your prompts. So why MariaDB for RAG solutions? I mean, you could be doing this in Python and just, how many of you use Python and pandas, for example? A few hands. So you could be saving just some vectors locally when you're running this. But the point is, when you're scaling a bigger solution, you'll be needing a large database. You'll be communicating with actual end users somewhere. Their data is in that database. So it makes sense to have everything in the same place, in the same open source database. And one point is, you want to know where the information is from, step by step, see how you produce results. Also, using the index, you don't want to be recreating that every time you make a query. And yeah, save costs. When you're doing the searches in your own database, you're not using a proprietary vector database in the cloud, you're doing it in your own open source database. And this point 6 is also important. Those that have been using AI with API, you know that tokens can get very expensive. So the smaller context you have, the less it costs. So Google Gemini has a 1 million token context window, which is great if you perhaps do it once, but if you're building an AI app where you want people to be constantly doing queries, then you want to feed quite a small bit of information with that to the LLM each time the user is asking something. So doing RAG, finding the most relevant chunks helps also to keep costs down. And open source databases are also cheaper. So there's some more slides in this presentation that go further in on details, technical details on how to use MariaDB, creating the table, some Python syntax examples, schemas illustrating RAG. So there's a lot of material available on our MariaDB's website. But I'd perhaps like to point out two things. One is that, as I said, RAG is not a solution you can use as such immediately on anything. You have to give it some thought and adapt it to your particular use case. And we actually have an AI RAG hackathon going now at the moment, and we have several participants at the moment, and those results will be shared at the Helsinki Python meetup in May. So it will be really exciting to see more RAG examples such as the one I mentioned earlier, be able to share those after that event. And another thing I'd like to point out were the integration frameworks that I was mentioning earlier. It's a good way to get into RAG, so if you want to try it out quickly and you want to use MariaDB, try LangChain or Llama Index if you're using Python, which is an easy place to start. So I just wanted to mention those. And that's what I had to tell you about RAG and MariaDB Vector for this time. I hope I gave you an insight to what RAG is and what kind of things you need to take into account when building a RAG solution. Thank you. I'd love to take some. I'd love to take some questions if you have
any. You mentioned that one step in the process was to find the appropriate chunk unification. How do you do that? How do you find which one is appropriate?
the appropriate chunk size.
Yes.
I'm practical, so I try. I test it. Yeah, my experience is you just have to try it out. I mean, sometimes you'll have a document that is nicely laid out, so it's very clear that this page is about this certain topic, and then it's very easy to focus, like, okay, take this. In other cases, you have documentation that is flowing a bit from one thing to another, and then you'll need to, like I said, you might pinpoint a certain part, but you need to feed the LLM a much larger part of that. But in practice, what I've been doing with RAG is in the chunkification process, I've done several different tests. I mean, it's quite cheap for a smaller subset, do this different size, and then you test it, how well it's sort of, for this case, working. Thank you.
So, I have understood that the different vector databases support different retrieval methods. And does MariaDB only support the nearest neighbor set?
So let me find the right slide. So yeah, so we have nearest neighbor search, yes, and we're using the HNSW technique for that, which is one of, one of the standards way to do it. Is there any other type of search method you're looking for? So there's also, you can do it with Euclidean or cosine, depending on what mathematical vector method you want to use. But is it some other method you're after?
Yeah, there are some keyword filtering or BM25 algorithms, some different types of retrieval methods that exist out there.
Did you say BM25?
Yes.
Yes. So no, I'm not an expert on that one, but as I understand that one, yeah, has a. Actually, I'm not. I don't want to comment it. I'm not.
That's all right.
I don't know more about. But yeah, that's another way to do it. Yeah.
I also wonder, do you know something about just for vector search? I've noticed that it works differently when the data is homogeneous, and it has a harder time finding the right document or chunk when you have data that's very similar to each other, and that might not be the best retrieval method to use if the data looks like that.
Yeah. No, I understand. Yeah, if it's true, if the pieces of text are producing similar vectors, then it's going to have a harder time of pinpointing it. And I guess whatever vector search you're using, you're going to have the same challenge with that. There are some ways to sort of get around that. One would be to, well, I've seen people do the solution that you summarize the text or do keywords, ask an LLM to pre-process the text to give you keywords for each chunk and to get the, what's it called? Yeah, to enhance the detail that is different between them. So that sort of pre-processing can help.
Thank you.
Any more questions?
No? Well, good questions. Thank you very much. Happy you came here to listen to this.